Assalamualaikum my dear students. Welcome to your chemistry class of standard 9. Hope all of you are fine and safe. We are in chapter 2, states of matter. Today I will discuss about diffusion and effusion process. At first, diffusion process. What is diffusion? The tendency of solid, liquid or gas to spread spontaneously and uniformly in any medium is called diffusion. That means diffusion is just a dispersion process of solid, liquid or gaseous substance in any medium. For example, follow here, this is the diffusion of potassium permanganate into water. That means inside this test tube there is water and this violet color substance is actually potassium permanganate. Here potassium permanganate is a solid substance like this. So when you keep a small piece of potassium permanganate inside this water, then the color of this potassium permanganate is gradually dispersed all over the water like this way. So this dispersion of potassium permanganate is actually diffusion process. Here solid potassium permanganate spread spontaneously and uniformly in liquid medium. Now the molecular structure of this diffusion like this way. Suppose these are the molecules of potassium permanganate. So when you keep this potassium permanganate inside the water, then they are spreading like this way. Now follow the more examples of diffusion. Already you have seen solid potassium permanganate diffused in water medium like this way. Also, if you use liquid dye inside the water, then that dye particles also diffused inside the water like this way. Suppose when you use liquid blue in water, so similar type diffusion process occurs there. So here liquid substance diffused in liquid medium, here solid substance diffused in liquid medium, and here liquid substance diffused in liquid medium. Its molecular structure will be like that. Follow here, this is drop of dye, liquid dye. So dye, how dye is spread, dispersed all over the water. These white balls are actually water molecules and these red color balls are dye molecules. So I hope you understand clearly how a solid or liquid substance diffused in any medium. Also gaseous substance can be diffused in a medium. For example, if you keep a bottle of perfume in a corner of a room, then after some times you will smell that you will get that smell all over the room. That means here perfume particles are diffused in air, that gaseous perfume particles are diffused in air medium, gaseous medium. So in that cases we will tell here gaseous substance diffused in gaseous medium. So like this way, actually in any solid, liquid or gaseous substance, when spread uniformly in any medium, it can be liquid or gas. In that time, that process is known as diffusion process. Now we will know about rate of diffusion. Generally, spreading of substance per unit time is called diffusion rate. That means what amount of substance per unit time dispersed in any medium is known as diffusion rate. If a substance takes less time to diffuse, its rate of diffusion is higher and vice versa. That means If any substance takes less time, then its diffusion rate will be high, and if takes more time, then the diffusion rate will be low. Now, factors affecting diffusion. That means diffusion rate affected by some factors such as temperature. If temperature is increased, rate of diffusion is also increased, and if temperature is decreased, rate of diffusion is also decreased. That means if the temperature is increased of the medium, then the rate of diffusion increased. How? Because in that cases the kinetic energy of the diffused particles will be increased. We know that if temperature increases, then kinetic energy or motion of the molecules also increases. For this, their diffusion rate is also increased. Now, state of matter. The rate of diffusion of gaseous matter is the highest, then the liquid, and solid has the least diffusion rate. That means you know that gaseous substance, their kinetic energy is most. For this, their rate of diffusion is also most. And the last point is mass. If the mass of the component is more, its rate of diffusion is less, and vice versa. Yes, because heavy particles diffused slowly and light particles diffused quickly. So if the mass of the component is more, that is heavy, so its diffusion rate will be less. Now follow the example. This is hot water, this is cold water. So if you fill a piece of potassium permanganate in hot water and same amount you fill in a cold water, then easily you can observe that in hot water diffusion rate is high. That means that solid particles diffused quickly, and in cold water the solid particles diffused slowly, because here the temperature of the water actually increases the kinetic energy of the potassium permanganate molecules. Now we will know about the matter of mass. The rate of diffusion depends on molecular mass. If the mass or molecular mass of a component is more, it will take more time to diffuse and its rate of diffusion will be less. And on the contrary, in the same way, if the mass or molecular mass of a component is less, it will take less time to diffuse and its rate of diffusion will be more. Here I have shown some molecular mass of some substances. For example, the molecular mass of hydrogen is 2, oxygen 32. Like this way you have to determine the molecular mass. Water 18, ammonia, nitrogen 14, for 3 atoms of hydrogen 3, so 17, carbon dioxide 44. You know that. Now how the question may come, follow here. The question may come like this way: compare the diffusion rate of hydrogen, nitrogen, hydrochloric acid and carbon dioxide, etc. Or this question may come like this way: which one will diffuse first among these gaseous substance? Or also it may come like this way: which one will diffuse at last among these gaseous substance? So question may come like this anyway, but you have to write the answer like this way. We know the rate of diffusion depends on molecular mass of the component. The molecular mass of hydrogen, nitrogen, hydrogen chloride gas and carbon dioxide are calculated below. Follow here. At first you have to calculate the molecular mass of those gaseous substance. Then you have to compare the molecular mass at first. Follow here. The molecular mass of the carbon dioxide is highest, then hydrogen chloride gas, then nitrogen gas, then hydrogen gas. And you know that more molecular mass, less diffusion rate. So the diffusion order of diffusion rate will be reverse of the molecular mass, isn't it? The molecular mass of hydrogen is least, so its diffusion rate will be high. Then nitrogen, then hydrogen chloride gas, and at last carbon dioxide gas. So according to question, now you have to conclude your answer. If you have to compare the diffusion rate, then up to this your answer. And if question like this way, which one will diffuse first, so you have to write from the above discussion. We can see hydrogen gas will diffuse first because its diffusion rate is high. And if the question may come like this way, in that case you have to write. So from the above discussion we can see the carbon dioxide gas will diffuse at last because its molecular mass is highest here. Like this way you have to write the answer. Also, in another way, the rate of diffusion may come like this way, where white smoke is produced inside the test tube. Over here, this is a glass tube, and here from this end there is used what? Cotton wool soaked in ammonia solution. That means this cotton is soaked in ammonia solution, and in this end there is used cotton wool soaked in hydrogen chloride gas. So when you use this two cotton, so from here ammonia gas and from here hydrogen gas, they are diffused inside the glass tube, and when they meet they will produce white fume. Why? Because you know that ammonia gas and hydrogen chloride gas react together and produce ammonium chloride, and the white smoke actually for this ammonium chloride. So when they meet together, there is produced white fume of ammonium chloride gas. Now our question is, where white smoke is produced inside the test tube? That means in which end this white smoke or white fume of ammonium chloride is produced? Near about the ammonia soaked wool end or near about the hydrogen chloride soaked wool end? Let's calculate the molecular mass of ammonia and hydrogen chloride. Then easily we can determine the in which position white fume will be produced. So at first you have to calculate the molecular mass of ammonia, that is 17, and then hydrogen chloride, that is 36.5. Now you can easily decide in which side. Follow here, the molecular mass of ammonia is less than that of hydrogen chloride, and so ammonia will diffuse more. Ammonia will diffuse more to the another end, and hydrogen chloride gas, its molecular mass is more, so it is diffused less to the another end. So for this, from the end of near about hydrogen chloride, in this place white fume will be produced, not in this side. If you indicate in this side white fume will be produced, then that will be wrong, because here hydrogen chloride diffuse less and ammonia will diffuse more for the less molecular mass. So like this way rate of diffusion may be determined. Now I will talk about effusion process. Follow here, the passage of gases from a high pressure zone to low pressure zone through a fine pore is called diffusion. My dear students, actually diffusion and effusion is same kind of process. Diffusion is a dispersing or spreading process. Effusion is also dispersing or spreading process of any substance. But where is the difference here? Diffusion, there is spreading process of any substance uniformly or spontaneously in any medium. There is not barrier. But here effusion process, in this effusion process we can see the passage of gas from a high pressure zone to low pressure zone through a fine pore. Follow this picture. This is the balloon, and inside the balloon there is a gas, isn't it? So if this balloon is leak out, that means a tiny hole is created on the surface of the balloon. This is the tiny hole. Then what will happen? The gaseous molecules inside the balloons comes out side through this tiny hole, isn't it? This process is known as effusion. Here these gaseous molecules are also spreading, but here pressure is a factor. Here these gaseous molecules from the high pressurized zone comes out through a tiny hole to the low pressure zone. This process is known as effusion process. So when the gaseous molecules from the high pressure zone comes out through a tiny hole, this process is effusion. And when these molecules are spreading now uniformly, this process is known as diffusion. So this is actually mainly effusion process. For example, air slowly leaking out of a tire. That means when a tire of vehicles are leak out, in that time effusion process occurs, because air from the inside of the tire comes out through the tiny hole. Or also helium leaking out of a balloon, like this way. Also more example, when we spray anything, perfume, then insect killers, etc., in that time what? When we press, then the gaseous molecules comes out through the tiny hole from inside of the container. So this is also a example of effusion process. So I hope you understand the diffusion and effusion process, and the factors affecting effusion process is also same as diffusion. That means temperature, molecular mass, etc. Similar of diffusion process. So now we can easily compare between these two processes. Follow here. Net passive movement of particles, that is atoms, ions or molecules, from a region in which they are in higher concentration to region of lower concentration. That means diffusion process is actually spreading of substance from high concentration area to low concentration area, and diffusion process is passing through a small hole. Occurs in solid, liquid and gas molecules, we have seen, but here occurs only in gaseous molecules, because diffusion process only occurs in gaseous substance. Molecules move freely through space. Movement of molecules occurs through tiny holes. So like this way you can easily compare between these two, diffusion and effusion process. So today up to this, I hope you understand these two process. So my dear students, you will watch this video more and more and try to understand properly, and please note the lecture from this video class carefully. So today up to this, goodbye everybody.